Alright everyone, welcome back to the end of 4.3. This is part 2 of the lesson, of course. So we are basically going to be talking about Venn diagrams, which is another way to kind of describe the probability of multiple events. Alright, so it's going to be leeching off a lot of what the last lesson was talking about, so hopefully you can use that knowledge and mastery to succeed at this one as well. So, here are our objective for today. And we have exactly one objective. And that is to just use Venn diagrams to find probabilities of multiple events. So we're going to spend a little bit of time here to talk about it, hopefully around 10 minutes or so. You'll be able to know, of course, based on video length. So let's get into it. So first of all, what is a Venn diagram? You probably know what this is, but it's basically one or more circles surrounded by a rectangle. Now, the surrounded by a rectangle part is actually very important. It's a part that people usually forget about, but I'll remind you of it over and again. But each circle represents an event, and the inside the rectangle represents the entire sample space of chance process. So then it says see figure 4.4. Well, what figure is that talking about? This one. Okay, so here's our square-ish box rectangle thing, and we have two circles representing an event A and an event B. This is how Venn diagrams are used in probability to describe the outcomes of a chance event, a chance process. So, how are we going to apply this to what we already know with the two-way tables? Well, let me show you what we did last time. If you don't remember this, here's a nice little refresher. You may want to have this out for your last notes also. But last time we talked about Facebook and Twitter users as a way to, talk about two-way tables. So we can explain the same information. Remember that A was about Facebook users and V was about Twitter users. Okay, so what is the probability of A? The probability that you select a person who has a Facebook out of any population, because this was percent based, remember. I'll give you a sec to look at that. Okay, hopefully you answered correctly there. You can see the feedback and stuff. So, yeah, we could also figure out what event B was, but I'll save you the little doldrums there and put you through with this. So, I've highlighted the blue column here, event A, and the red row, I guess not a column, is event B. So these are the two events we care about, our A and our B, and you can maybe kind of see a Venn diagram-esque shape based on just the two rectangles that I've used to highlight the corresponding rows and columns. And if you can't see it, that's all right. I'm about to put it out here for you visually. So, there's our circles, our two circles. I've omitted the box for now. We're not going to worry about that at the moment. But here's our two circles. The blue represents the space of event A, right? And the red represents the space of event B. Okay, so let me ask you here, what number do you guys think goes in that middle circle based on what you see in the table right now? Give you a sec to look at that. Okay, if you said 15, you are right on the money, so obviously, in here you can see that the box around it has both colors, which means it probably includes people who have Facebook and a Twitter. If you just read the little labels here too, and based on what you know last time, this should be fairly easy to suss out. And so this middle intersection, okay, represents the people who have both a Facebook in the blue circle and a Twitter in the right circle, the red one. All right, well, let's figure out the rest of the numbers here. You might be thinking that this circle space that's not inside the intersection might represent 71 and this might represent 33, but they actually do not. Okay, so let's talk about this a little bit. Remember that the blue circle represents all of the Facebook user base, right? All people who have Facebook fall in this blue circle. So everything inside, including this intersection space, has to add up to 71. That's why this area only represents the 56 you see in the table right here. Okay? Because 15 plus 56 is our total of 71. That's the whole circle. The same applies for the red circle, the Twitter circle. 15 here in the middle plus 18 here in the just Twitter zone will give you the 33 that makes up the whole circle. Okay, well that's all good and fine. Okay, this is our two circle setup. But remember, a Venn diagram needs a rectangle outside of it. So, here we go. This is the Venn diagram for our situation. I've moved the numbers a little bit up, I've blown up the picture a lot bigger, and I've given it a rectangle. So, take a look at our definitions here, pause the video, to write all this down. All right, but remember, this top part is the sample space, and these all represent event types, okay, in our formula, okay, our probability notation, okay. So P, A, and B represents this intersection. P of A is the whole blue circle. P of B is the whole red. Okay. And then this space outside the circles, which is neither a Facebook user or a Twitter user, nor, I guess is the grammatically correct way to say it, okay, represents an event where neither event occurs. What is that number? What do you guys think? Refer to the two-way table to help you. Okie doke. And the answer, of course, is 11. Okay. You may notice that this is the last number in the top four, I guess, four square of a two-way table that was not included in our numbers already. Okay. And so this is our 11. 11 people fall, 11%, I should say, of people fall into this category where they don't have a Facebook or a Twitter. Okay. This is not the 100 that you see that it makes up the whole space. Okay. But something very interesting, and I think is definitely worth noting, is that this should follow the rules of our probability that we've set out for ourselves. If you add all the numbers up, which you can go ahead and do that, the sum of all these numbers should come out to 100, as in 100% of the sample space. This, of course, makes sense. If you shade in the whole thing, then 100% of the area is filled out, right? So that hopefully makes sense to you, okay, where the complement of A and B, or A or B, I suppose, is out here, and everything else inside represents an event A or B, okay, where this is our intersection A and B. All right, now there are a couple more little things about Venn diagrams that I think I can show you that'll be very useful in processing the visual information. If you're a visual learner and this is making a lot of sense to you, then I highly suggest continuing to use this. It's very intuitive, I feel. But if you are getting a little lost, maybe the two-way table is a bit better for you. But either way, here's the rest of the visually important representations. Here's our first one, represented with a little A. This shaded area in here represents the complement of event A. Okay, so if you're talking about A, the circle, this represents all the events under A. Then A complement is the place outside of it. Okay. All right, and here's our second one. The visually useful representation here, talking about the intersection one more time, and this is some new notation we will get to in a sec, but this is the intersection of events A and B. Both events are occurring here. Okay, and finally we have our C. Okay, this is the final representation, the one that we were talking about last time, but this is the union of events A and B. We have this little U. We'll talk about this in just a sec as well. Okay, so when we talk about intersection union, those might have been words you've heard me say, okay? Maybe not union, but definitely intersection. Here is the formal definition, including the probability notation of intersection and union. You may know them as event A and B, or event A or B. Okay, so from now on, we will use this probability notation. It'll be very important to have it kind of understood. Okay, understand this notation. Okay, so I'll give you a second to write all this down. All right, so if you stuck around for the practice, okay, here's another representation of the complete visuals on a Venn diagram using those numbers we used in the practice slides, the pierced ears versus gender survey. And so you can see here, event A, which is the probability that the person is male, is a 90. Okay, this includes everyone, okay, because it's not just talking about the space without the intersection. We've got the space where people have ears pierced. That's, of course, the entire population, okay, there as well. And finally, we have 19 on the inside to represent the double double counted area. Okay, so this is why the formula for the general addition rule works visually, and the outside is neither event A or B. So this is the complement of A or B, I guess you could say. So let me ask you this question. If I wanted to find out the probability of a female person being chosen without pierced ears, what would that probability be? Take a look at the numbers and try to figure it out. All right, hopefully you got a lot out of this video. If you have any questions, bring them to class, prepare to talk about them, the Venn diagrams. I really think these are pretty standard and easy to understand if you understood two-way tables. They might even be easier, depending on whether you're visual or not. But at the end of the day, if you can answer this question to yourself, can you use Venn diagrams to find the probability of multiple events? Then you've made it. Congrats. I'll see you guys in class.